Okay, let's unpack this. Today, we're diving into a really fascinating collection of sources. It's all about the cutting edge fusion of artificial intelligence with cloud, edge, and mobile computing. It's truly the next frontier of innovation, isn't it? Our mission today is basically to pull out the most important nuggets of insight, helping you get well informed quickly about this rapidly evolving landscape.
Yeah, and what's truly fascinating here, I think, is how these sources paint such a comprehensive picture. It shows how advanced AI isn't just, enhancing things a bit. It's fundamentally reshaping industries and user experiences across the entire computing continuum. We're talking about a monumental shift in capabilities and, well, what we can actually do with technology.
Exactly. Think of it as your shortcut to understanding the revolution happening right now. We've got sources delving into everything from how computing power is traded almost like a commodity to how AI catches those hidden anomalies, manages vast resources, secures our smart environments, and even optimizes our future 6G networks. It's all about intelligence getting closer to where the data is generated, closer to us. The deep dive. Intelligent computing across the continuum. The deep dive. Optimizing and securing the computing landscape.
Right. Let's kick things off with how AI is supercharging cloud computing. Most of us think of the cloud as the traditional big brain of the internet, right?
Yeah, the central hub.
You might imagine it as just these massive data centers, but with AI, it's becoming, well, incredibly intelligent. How exactly is AI transforming these behemoths?
Well, it's a real game changer. These sources highlight that advanced AI in the cloud is amplifying traditional capabilities, particularly in data insights and predictive analytics. You've got machine learning algorithms processing just colossal data sets, allowing businesses to extract really meaningful insights for, well, everything from forecasting market trends to instantly optimizing complex supply chains. It truly supercharges how businesses make decisions, letting them use all that data to move faster and smarter. Okay, so beyond just insights, it's also about making the cloud incredibly flexible, right?
Absolutely. The marriage of cloud computing and advanced AI enables unparalleled scalability. Businesses can effortlessly scale computational resources based on demand, which gives them incredible agility to respond dynamically to evolving requirements. And for cloud-based applications, it means incredibly personalized user experiences, from content recommendations to tailored services, by understanding and anticipating user preferences almost before you even know them yourself.
Now, here's where it gets really interesting for me. These sources introduce some very specific AI systems making this happen. Take anomaly detection in the cloud, for instance. It sounds maybe a bit niche, but I imagine it's absolutely crucial for quality of
Oh,
service.
it's vital. A critical challenge in these complex, high-variability cloud environments is detecting anomalies that might be subtle or
Right.
lack clear labels. The CAT-IADEF method described in our sources addresses this. That's convolutional adversarial training-based integrated anomaly detection with explanation framework. Bit of a mouthful.
Uh-huh, yeah.
But it uses multiple convolutional neural networks and, crucially, adversarial training. This increases robustness and can even sort of exaggerate minute anomalies, making them easier to detect.
So it actively looks for the tiny weird things that other systems might miss. That's clever. And it also dynamically sets thresholds for detection, which sounds really important given how fast data can change in the cloud.
That's exactly right. It uses the peaks over threshold, or POT approach, to dynamically decide the detection threshold in real time. Experimental findings showed CAT-IADEF outperforming both classical methods like PCA and even newer deep learning methods, especially in its ability to discern these subtle anomalies. And that adversarial training part, it's critical. Performance drops significantly without it in the tests.
Okay, so shifting gears a bit from the big cloud to something closer to home edge computing, we've got sources talking about edge AI services. What does it actually mean to bring AI to the edge?
Yeah, if we connect this to the bigger picture, edge AI means AI processing happens near the network's edge. So close to you, the user, and right where the data is generated, rather than sending everything back to a distant cloud data center. This is a game changer for the Internet of Things, IoT. Smart devices can process data locally, reducing dependence on centralized cloud resources and enabling faster, more efficient decision-making right there on the spot.
So what does this all mean for how we handle computing power, especially with all these new devices and AI demands popping up everywhere?
Well, this brings us to a really fascinating concept called the AI Bazaar. It's a power trading framework for cloud edge computing. See, the challenge is, while AI applications are booming and IoT is expanding, individual edge nodes often have limited resources. This leads to underutilized computing power in some places and, well, allocation disparities in others. AI Bazaar proposes a trusted framework like a marketplace for trading computing power, and it leverages blockchain's proof of useful work, POUW consensus protocol.
A marketplace for computing power run on blockchain. That's a pretty unique application. And the source mentions something called the PBMRL algorithm using the win or learn principle. How does that help?
Okay, so the PBRRL algorithm is designed to achieve equilibrium in this AI Bazaar, basically ensuring equitable profits for both the AI consumers who need power and the computing power providers who have spare capacity. Simulations showed it significantly outperforming other algorithms like minimax Q-learning in achieving this balance. It's also interesting they found that as the number of AI consumers increases, individual utility might decrease slightly due to competition.
Makes sense.
But the overall utility for the computing power providers can actually rise. It kind of democratizes access to power.
Right. And beyond just trading power, AI is also crucial for managing resources efficiently in these hybrid environments. Our sources highlight something called CRUZE, which uses a cuckoo optimization algorithm. Sounds intriguing.
Yes, CRUZE. It's an AI-based solution for holistic resource management, specifically focusing on sustainable cloud computing. Cloud data centers consume immense energy, especially for cooling. That can be as much as the computing nodes themselves.
Wow.
So CRUZE aims to optimize energy effectiveness, shorten carbon footprints, and reduce service failures. It manages servers, networks, storage, and the cooling systems together. It's designed to navigate that inherent trade-off between increasing server availability and dependability and reducing energy consumption.
Ah, okay. So if you consolidate VMs, virtual machines, to save energy, you risk failures.
Exactly.
But if you duplicate them for reliability, you use more energy. CRUZ is trying to find that sweet spot.
Precisely. And its performance in the studies was impressive, reducing energy consumption by 16–19% compared to other methods, increasing CPU utilization, and significantly improving cooling efficiency, what they call DCS effectiveness. It really shows how AI can tackle these complex optimization problems in sustainable computing that humans find really hard to balance perfectly. AI for security, sustainability, and future networks.
Now let's talk about something incredibly important. Privacy and security in our increasingly smart world. AI isn't just about efficiency, it's also proving to be a powerful tool for protection, isn't it?
Absolutely. And this raises an important question about how we ensure public privacy and security in these smart environments. They're becoming more complex, due to rapid urbanization. The sources describe using a feed-forward backpropagation neural network, BPNN, for a data resource management, or DRM, framework.
So using AI to predict and alert us to risks in real time, that sounds almost like science fiction.
Well, it's becoming reality. The BPNN method evaluates variables impacting urban public privacy and security, everything from natural catastrophes and flu outbreaks to potential terrorist acts. It anticipates indexed statistics in real time, allowing for risk surveillance and timely alerts. And the results are compelling. The BPNN method achieved a mean prediction performance of around 89%. That significantly outperformed conventional neural network methods. And it had a hazard alert accuracy over 90%.
That's fantastic. It means potentially earlier warnings for everything from, say, urban smog levels to landslides.
Precisely. And if we connect this to the bigger picture, it underscores the importance of not just collecting data, but having intelligent systems that can process, interpret, and act on it for public safety. The future implications suggest really prioritizing privacy and security in these systems, using secure encrypted data, maybe, and developing user-friendly interfaces for local authorities and citizens.
Okay, staying on the topic of pervasive technology, what about wireless sensor networks, WSNs? They're literally everywhere now, from industrial settings to environmental monitoring, but they often have very limited resources.
Yeah, the sources really highlight WSNs' intrinsic limitations. We're talking processing power, memory, energy, which makes achieving high quality of service, QoS, incredibly challenging. Traditional static methods often just fail in these dynamic environments. AI, however, emerges as a bit of a game changer here for optimizing parameters like latency, reliability, and energy efficiency.
So AI helps these tiny sensors become smarter and more reliable, even with their constraints. That seems like a really tough problem.
It is, yeah. But by leveraging machine learning and deep learning, WSNs can adapt to changing conditions in real time. They can enhance fault tolerance and self-healing capabilities and optimize data routing. Our sources actually conducted simulations comparing different algorithms for WSN performance.
Whoa, what stands out to you from those comparisons?
Well, the recursive support vector regression, RSVR algorithm, consistently showed superior performance across key metrics. For packet delivery delay, RSVR achieved a rate of only 3.9%.
Pretty low.
Yeah, compared to SVM's 2.3% and KNN's 4.6%. For security performance, RSVR had higher precision, hitting 91-92%, compared to SVM's 76-82% and KNN's 87-91%.
Big difference there.
And for time complexity, RSVR consistently reduced processing time. This efficiency is absolutely critical in resource-constrained WSN environments. But, AI in WSN still faces challenges. Resource constraints for complex algorithms, data privacy is always a concern, and adapting to highly dynamic environments.
That's where the vision of 6G networks comes in, isn't it? The idea that AI will be baked into the very fabric of future wireless communication, moving beyond just connecting devices to enabling intelligent connections.
Yes. Edge AI is seen as a disruptive technology for 6G. It addresses challenges like privacy breaches, network congestion, energy consumption, and latency during both inference and training. Enabling technologies include things like distributed machine learning, think swarm learning, and decentralized reinforcement learning for sequential decision-making in dynamic multi-agent environments.
So it's not just about AI for networks, but also networks for AI, like a symbiotic relationship.
Precisely. This deep integration aims to build a co-design principle, merging learning and communication for 6G. This facilitates applications in areas like autonomous driving, needing real-time data analysis, ultra-low latency, robust security.
Crucial stuff.
Yeah. The Internet of Things, AIoT, which includes semantic communication transmitting only pertinent information, not just raw data. And intelligent healthcare, unified platforms for health monitoring, precision medicine, even clinical disease identification using federated and swarm learning.
And for all of this, network efficiency is absolutely key. Our sources talk about a clever solution for QoS using an adaptive network algorithm.
Right, the AMRA. That's active and adaptive, multiple paths routing algorithm. It's proposed to overcome the limitations of conventional network designs in providing QoS and managing congestion. It uses software-defined networks, SDN, and OpenFlow for centralized management.
So instead of static routes, the system dynamically finds the best pathways for data.
That's right. AMRA actively optimizes resource allocation by combining bandwidth based on real-time network conditions. It significantly reduces packet loss and end-to-end latency by intelligently distributing data streams across multiple efficient pathways. Simulations showed AMRA improving QoS by an impressive 35–70% compared to traditional single-path and ECMP techniques. It demonstrates excellent flexibility in adapting to bandwidth variance. Really smart networking. 3. AI's real-world impact: commerce, banking, and sustainability.
Okay, let's zoom out a bit now and see how all this advanced AI is actually impacting our daily lives, particularly in e-commerce and banking.
Yeah, the sources detail AI's widespread adoption in these sectors. It's pretty pervasive now. In e-commerce, it's transforming operations through intelligent assistants or chatbots. They provide product recommendations, handle inquiries, even assist with payments, significantly lowering labor costs and improving service quality.
And pricing, too, I imagine, with all that dynamic market data constantly flowing in.
Yes, optimal pricing is another key application. AI processes enormous volumes of data, continuously monitoring market dynamics to adjust prices. It considers factors like product evaluation, logistics costs, service quality, all in real time.
The case study about Baidu Takeout seems like a great example of this in action.
Absolutely. It's highlighted as the first takeout system to use streaming computing and a smart scheduling algorithm. By integrating intelligent scheduling and recommendation systems processing user history, delivery status, real-time scenario data, Baidu Takeout was able to cut average user wait times by 28%.
Wow, that's significant.
And raise order delivery efficiency by 100%. It really illustrates the power of AI to transform complex logistical operations.
And in the banking industry, how are we seeing AI products making a difference there? Similar patterns?
Pretty similar, yeah. Chatbots are improving customer relationships and promoting mobile banking services, helping banks cut costs while maintaining customer service.
Yeah.
But beyond that, AI is critical for risk evaluation, accurate credit evaluation, fraud detection, money laundering prevention, all driven by sophisticated algorithms that can spot patterns humans might miss.
Okay, moving from the digital economy to something maybe even more fundamental: our planet's well-being. The sources discuss sustainable green human resource management, GHRM, using AI. This is a fascinating intersection, people, planet, technology.
It really is, and it raises an important question. How can human resource management contribute to environmental sustainability?
Yeah.
The sources explain that GHRM aims to integrate green policies directly with HR practices, improving environmental outcomes within organizations. With global warming and environmental challenges, traditional HRM methods are, frankly, seen as dated.
So AI is helping businesses become more environmentally friendly from the inside out through their HR practices. That's not something you typically connect.
Precisely. The research reviewed in these sources used data mining techniques to identify trends and key areas in GHRM. It showed a steady increase in publications on this topic, peaking recently, so it's definitely a hotly debated topic. AI can assist in detecting obstacles and implementing green practices. For instance, facilitating online HR operations to reduce paper use, promoting eco-friendly recruitment, maybe even analyzing commute patterns for remote work policies.
Interesting. And finally, we have the ultimate goal, natural resource management, NRM, for sustainable development. This is tied directly into the UN's Sustainable Development Goals, the SDGs.
Yeah, and this is where AI's transformative potential truly shines, I think, with increasing population growth, urbanization, environmental degradation. Challenges like climate change, biodiversity loss, resource depletion are incredibly pressing. AI, with machine learning, data analytics, remote sensing, it enhances our capacity to monitor, analyze, and make informed decisions about our environment.
So it's helping us manage our planet's resources better, at scale.
Yes. AI-driven predictive models can forecast resource availability and demand, enabling more efficient allocation. It's used for wildlife conservation and habitat preservation, tracking endangered species, detecting poaching, analyzing ecosystem health. And what's more, AI can potentially help democratize information, making NRM discussions more accessible to communities and individuals, ensuring sustainability becomes a collective effort.
That's a huge shift, empowering more people with critical knowledge about their own environment.
It is. However, the sources also highlight the challenges, things like data privacy and security, especially with regulations like GDPR. Ensuring data quality and availability for the AI models is crucial too, and adequate resource allocation for integrating these technologies. Despite these hurdles, the commitment from countries like Germany and Poland to leverage AI for SDGs, especially in healthcare, transportation, energy, agriculture, that's clear. Collaboration between governments, industry, academia, civil society, that's going to be crucial to ensure AI technologies align with sustainable development objectives. Outro.
So what does this all mean for you, listening in? We've seen how AI is not just some buzzword anymore. It's a fundamental force reshaping everything from how computing power is traded and secured to how we manage our environment and conduct our daily business.
Yeah, if we connect this to the bigger picture, the profound convergence of AI with cloud, edge, and mobile computing, it's propelling us into a new era of intelligent interaction with technology. It's really about bringing processing power closer to the data, making systems smarter, more efficient, and much more responsive to our needs and the needs of our planet.
It's about turning these vast amounts of information into actionable insights, those aha moments, giving you a shortcut to being truly well-informed in this complex space. The potential is immense, but it also comes with responsibilities, doesn't it?
It certainly does. And this raises an important question for you to consider. As AI becomes more deeply integrated into every aspect of our digital and physical worlds, how do we ensure that its development is not just innovative, but also ethical, secure, and truly serves the greater good for all?
A powerful thought to leave you with. Continue to explore, continue to question, and embrace the ongoing journey into this intelligent era. Until our next deep dive.